Hello, and welcome to the tutoring video for Focus Quiz 4, Permutation and Combination. Alright, permutations and combinations are pretty related to the counting problems that we went over previously. So the term combination sounds very similar to the stereotypical outfit problem, right? And they are related. Most important at first is that you understand the difference between permutations and combinations. Permutations is where what you select from a group, the order matters, and or the slots you're filling are unique. So an example would be like, how many different ways can some runners finish in a race? Runners in a race? I have got to practice writing with this thing. And so another example would be like filling 3 positions from a group of people that are unique. So like the problem from last week where there were the kindergarten class had 3 positions it had to fill. That is technically a permutation problem, and you can use permutations instead of filling in those slots to solve it. A combination is something that we honestly deal with a lot more in regular life. So a combination is like a hand of cards. The order doesn't matter. If you have 2 kings and 3 eights, it doesn't matter which one is first in your hand. What matters is the combination of them. Another thing would be like if you had that same committee thing, but instead of filling 3 specific positions, you just had to choose 3 people to go do a task. That would be a combination of 3 different people. It doesn't matter who's first, second, and third picked. So you need to be able to tell whether a problem has to deal with permutations or combinations. Okay, an important thing to know, and this is not terribly complicated, is what the exclamation point after a number means. It just means factorial, and all a factorial is so like 5 factorial equals 5 times 4 times 3 times 2 times 1. I think I mentioned it in last week's videos, but that is what that means. And you can type into your calculator 5 factorial, and for you that is in with the little pi. No, it's not. Oh, it's over here. So you type your number and then the question mark exclamation button. You can choose exclamation from there, and that'll give you 120, which is 5 times 4 times 3 times 2 times 1. This is the formula for permutations. So previously, we did these types of problems filling in slots, right? There's an easier way to do it. So let's do this problem with our slot method, and then I'll do it with permutations. Quick side note, 0 factorial is 1. Just like anything to the 0 is 1. You just have to trust it. It makes sense. I promise. If there are 8 runners in a race, how many ways can first, second, and third place be filled? All right. So how we would do this, based on last week's instruction, is we would put down our slots to be filled with first, second, and third place, and we would say, okay, there are 8 choices for first, but then we've removed 1, so there's 7, and then there's 6, right? And this will give us, that's not the right window, 8 times 7 times 6, there are 336 ways for that to happen. Now let's plug in to our permutations formula, and you'll see that it ends up being the same thing. And it is important to know this formula and then subsequently the combinations formula. Maybe not immediately, but later on they will ask you questions, even so early as the first few competitions. They'll ask you questions that could be as simple as, what is the permutation formula? And then you have to know what it looks like. You don't really have to use it, but you'll have to know it. So if we fill in our stuff, we have n objects, we have 8 runners. So we're going to fill in our n's with 8. And our k is 3. We're selecting 3 objects. So we'll put that in there. So 8 factorial over 8 minus 3 factorial, which is 5 factorial. Do 8 factorial over 5 factorial, 336 as well. So they work the same way. In your calculator, instead of using this equation all the time, because the numbers can get big and it's just easier to know how to do this other thing, is you will go to menu, probability, permutations. So menu 5-2, and it will give you this NPR. And then what you do is you say, you type in the number of objects you are choosing from, and then how many you are choosing. So we have 8 runners, and we're choosing 3 to go in the first few places. And it also gives us the same answer. So this just fills in that other formula for you. And again, that's menu 5-2. And combinations is very similar, and you'll be using them a lot. And then I just wanted to show you that with this part 2, this would be more likely the kind of problem you got for like counting. This would just be 8 factorial, because we have 8, 7, 6, 5, 4, 3, 2, 1. So if you got this type of question, which you can in this same general area, and how many ways can they finish? It's 8 factorial. And if we plugged it back into this, because we're choosing 8, this just becomes 8 factorial over n minus k. That's 8. We're choosing 8 as well. So that becomes 0 factorial, which we know is 1. So this just is 8 factorial over 1. 8 factorial. That's the basics of permutations. Again, you'll need to know that. Don't stress too much if you don't know it for the first few quizzes, but this is taken directly from the Math Resource Guide, which especially for these focus quizzes 4 and 5, I would suggest you just look at and read, because I'll be showing you more examples. For a more in-depth explanation of what's going on, you should go to the actual resource. Combinations. So again, combinations are like permutations, except what we are choosing, we're choosing a certain number of them, but it doesn't matter in what order they are chosen or that they end up in. And this is actually a very common thing, especially if you do any statistics. You'll want to know this. This helps out a lot if you're going to take statistics later, and pre-cal, but to a lesser degree. So this is the formula for combinations, and it's very similar to the formula for permutations, except after that n minus k factorial, we add another times k factorial. So for the previous problem, if we had asked, well, this is about written like the previous problem. That was on purpose, so I'll show you that. There's a special notation for combinations that does not apply to permutations. So if you say you have, in this case, 8 options and you're choosing 3. We have 8 candies and we're choosing 3. You can write it like this, and that reads as 8 choose 3. You cannot do that with permutations. So in this case, we're choosing 3 candies out of 8 options. I'll fill in this equation. You cannot do the like slot method with this. That's more of a permutation adjacent thing. So we'll fill in, we have 8 factorial, and then that n minus k is going to end up being 5 factorial times k factorial again. And this does not come out to 8 factorial. That's not how factorials work. So let's go plug this in. 8 factorial over 5 factorial times 3 factorial, which you don't have to do the multiplication sign. It will add it for you. And that's 56. Because we can just write this as 8 choose 3. So we can go in, and for you, I say for you because I just type it in with the keyboard when I'm using this. But you go menu, 5, 3. So 2 is for permutations, 3 is for combinations, and that's NCR. You can also type out NPR and NCR, all lowercase, and then do the open parentheses and do this. I find generally the menu is a lot quicker. But anyways, 8, choose 3, 56. So you can tell you're almost always going to be using that NCR, NPR, just because it's so much quicker. I just wanted to show you early on how the formulas look and work, because eventually you will need to know that, even if you don't use it very often. All right. How many ways can 7 people stand in a line? This is asking something in which order matters. We only have 7 people. If this was a combination, it would be 1. 7 people can stand in a line, and as a combination, there's only one possible combination. But we want to know how many ways can they stand in a line, and this is implying order matters. And this is just 7 factorial. Much like filling in the slots from last week, it's just 7, 6, 5, 4, 3, 2, 1, multiply them all out. Pretty easy. There might have even been a problem on your focus quiz that was exactly like this. Okay. A certain candy shop lets you make your own jelly bean and M&M mix, which is disgusting. There are 8 flavors of jelly beans and 7 colors of M&Ms. If you can choose 5 flavors of jelly bean and 5 colors of M&M, how many distinct medleys can you make? So the first thing we need to determine is this permutation or combination. Since it doesn't matter what order we have the flavors of jelly bean and M&M in, or which we choose first, this is a combination problem. We're just mixing them all in a bag. Doesn't matter in what order we choose them. So then we have to figure out, what are we actually looking for here? We're choosing 5 flavors of jelly bean and 5 colors of M&M. We're choosing 5 flavors of jelly bean out of 8. So we'll write that as 8 choose 5. And then from the M&Ms, we have 7, and we're choosing 5 as well. And since we are choosing from 2 distinct groups, but they are being combined, the number of unique ways that we can make these medleys is the number of combinations of jelly beans we can have times the number of combinations of M&Ms we can have. And this will give you, and again, you're going to want to do menu 5, 3. This is a combination. We have 8 choose 5 times, and then you can also just type it out. And you know something has typed out correctly because they go from italics to bold or not italics, whatever that is in the calculator. And then 7 choose 5. And that is how many distinct medleys you can make of disgusting candy bag. All right. A group of 3 people can be chosen from 4 people named John, 3 people named James, and 7 people named Mary. And how many ways can this be done? This is a bit of a trick question. Because they're giving you 3 disparate groups here, and they'll do this, you might be tempted to do either permutations or assume that you're choosing 1 from each group. That's not the case. You just have to choose 3 people from this large group of people. And it's as simple as adding these up. 4 plus 3 plus 7, 14. And we're choosing 3 out of them. And that equals... And again, this is order does not matter. Beat that into your skull. 364. There are 364 combinations of 3 people from a group of 14. If it mattered the order they were chosen in, it would be a much larger number. So say if you had to choose, if they were in a race and they had to finish first, second, third, or they had to be specific positions, it would be different. This is a very common type of problem. This is a permutation problem, and that's because the order matters. You have a chair, secretary, and treasurer. So it matters in which order, or rather there are unique slots to be filled. And then we're also going to do the combination version. There are 9 people, and you are, I'll say picking because it's permutation. You are picking 3 positions. So 9, and you cannot write this as the big parentheses thing. That's only for combination. So I'll write it out like we would see it in the calculator. Permutation 9, 3. $504. 504 ways to fill in a committee chair, secretary, and treasurer. Now, if they were just choosing 3 people for the same kind of position, I put committee chairs, but it could be like 3 people have to go pick up hot dogs. It doesn't matter. It doesn't matter in which order they are chosen. It changes to this. And there's only 84 different combinations of people. So that number is much smaller, even though it's almost the exact same problem and looks almost the same as far as you will be dealing with it. That's why it's really important to understand whether what you're looking at is permutation or combination, because they're different, extremely different. This is a type of problem that will absolutely come up on the test. I do not believe it's on your focus quiz, but you really need to know how to do it. There's something kind of similar on your focus quiz, but it's not as complicated. In how many unique ways can you rearrange the letters in Mississippi? And the trick to this, so if all these letters were unique, it would just be however many letters there are factorial. But switching these S's doesn't actually make a new word, right? Switching the P's doesn't, so you have to account for that, and this is how you do it. On top of our little bar here, and this is going to be what a lot of kind of similar to what the next focus quiz looks like. There's a whole lot of setting up a bunch of stuff on top and bottom of a division problem. On top, we're going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 factorial. And if all these letters were unique, that would be how many unique ways you can rearrange the letters. But we have to put a bunch of stuff on the bottom because we have repeated letters. So for M, there's no other M, so we're going to leave it alone. For I, we have 1, 2, 3, 4 I's. So on the bottom, we're going to put 4 factorial. We're going to leave the next one. We have 1, 2, 3, 4 S's. Put another 4 factorial on the bottom. And then the only other letter is P. We have 2 P's and put 2 factorial on the bottom. And then when you type this out, that's how many unique ways you can rearrange the letters in Mississippi. What was it? 34,650. Again, this exact problem might come up. I saw this multiple times when I was taking tests. They like this word, but it goes for any word. You just count how many times each non-unique letter happens, and you put it on the bottom factorial. Cool. I would also like to reiterate that you really need to keep straight which type of problem you're dealing with, whether it's permutation or combination. And you'll get used to seeing that. Maybe you'll have no trouble with it at all. That's ideal. But that's the thing that you'll need to practice the most.